All right, math mates, we've got a lot to cover today on real numbers. I'm going to break it down as easy as possible for you. So when you look at this chart on the first page, don't get overwhelmed. We're going to do some practice problems. You will understand it. And if not, just send me some questions and I will be happy to explain them. But let's take a look at emoji Betsy. Oh my. Hey, math mates. I took a photo of myself and I put it in AI Arta, and that's what I got. I was wearing a bandana in the picture. I don't know if it really resembles me that much, but I thought it was cool to just put some AI stuff up here. So I hope you like AI Betsy. All right, let's go on. So today we're talking about real numbers. If you are looking at this, you may be doing a review for algebra or math 8, math 7. You might be just preparing for something in another class and you want to review. But for those classes, everything you know of is real. If you can put it on a number line, it's real. And a number line goes on in both directions infinitely. So -1 million, you can plot that on a number line. 3/4, 0.98, you can plot all of those decimals, fractions, positive, negative numbers. All can be plotted on a number line, so they're all real numbers. So everything I talk about today is a real number. So let's take a look at our chart here. On the top, we have real numbers, rational numbers, irrational numbers, fractions, integers, whole numbers, natural numbers, and zero are all real numbers. So let's make sure we understand that first. All the numbers we're talking about today are real numbers. So irrational numbers. Irrational numbers are numbers that are a decimal that goes on forever. It never ends. A good example of an irrational number is pi. If you take pi out, it's 3.1415, blah, blah, blah. It goes on and on forever. It never ends. That makes it irrational. If you take the square root of any prime number, it is irrational. And what's a prime number? 2 is a prime number. 1 times 2 is 2. Nothing else multiplies to 2. If you take the square root of 2, that decimal will go on forever. 3 is a prime number. 1 times 3 is 3. There's nothing else that multiplies to 3. If you take the square root of 3, you will get a decimal that goes on forever. It's irrational. Square root of 17. 1 times 17 is 17. Nothing else multiplies to 17. 17 is prime. So when you take that square root, you will get a decimal that goes on forever. Irrational numbers. Now let's take a look at everything that's a rational number. Integers, whole numbers, natural numbers, all are rational numbers. Integers, I have them listed there. Your integers are any number, positive or negative, and 0 that don't have decimals. Whole numbers are your positive integers and 0. So 0, 1, 2, 3, 4, 5, and so on. Your natural numbers are your counting numbers. We start counting with 1, 1, 2, 3, and so on. So the only difference between whole numbers and natural numbers is that whole numbers include 0. Natural numbers do not. Fractions. If you can take any integer, which is any number without a decimal, over any other number without a decimal, if you got a fraction like that, an integer over an integer, it's rational. So I'm throwing all this information to you about rational numbers, irrational numbers, integers, whole numbers, natural numbers. It's okay. We're going to do this. Let's do some sample problems nice and slowly to make sure that you understand this chart. If you understand that everything on that chart is a real number, we're golden. We've got it going on. We can do this. So everything on that chart is a real number. All right, Let's go on. La, 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 la. All right, number 2. Page 2, I should say. The first one's I already have done for you. So 0. 0 is a real number. 0 is also an integer. Integers are any numbers that don't have decimals. Integers are represented with the letter Z. When I teach it in class, I'm kind of a rebel and I use the letter I, but the word for integers comes from a German name. That's why it's a Z. And that's why you'll see some of these letters are different. But I kind of make up my own when I'm in class, just to make it a little easier on the kids. But for now, I'm going to just follow what is true. All right, whole numbers. 0, 1, 2, 3. It includes 0, so 0 is a whole number. And if it is a whole number or an integer, then it's definitely a rational number. So there we have it. All right, number 2, -4. So right away, we know that -4 can be put on a number line. So it can be plotted there. So we know that -4 is a real number. We also know that integers are your positive, negative numbers and 0 that don't have decimals. So is -4 an integer? Yes. Is it a whole number? Well, whole numbers don't include negative numbers, so no. Is it a natural number? Nope, natural numbers are counting numbers. We start counting with 1. But because it is an integer, it is rational. And the letter for rational is Q. So there we got it. How we doing, mathmates? If you want, stop the video and try the problems yourself before I give you the answers. 5.2, it has a decimal. If it has a decimal, it's definitely not an integer, whole number, or natural number because they don't have decimals. It's real. Everything here is real. I can plot 5.2 on a number line. And it's 5.2. It's 0.2. It ends. Because it ends, it's rational. So that's all we got for this one. How we doing, mathmates? Again, if it's better that you stop the video and practice them yourself, please do that. Number 4, 1/3, it's a fraction. That's real. But 1/3, if you do 1 divided by 3 on your calculator, you're going to get 0.33333 repeated. That's not an integer because it's a decimal. It's not a whole number. It has a decimal. It's not a natural number because it has a decimal. But 1 is an integer and 3 is an integer. An integer divided by an integer gives you a rational number. 0.3 is repeating. Repeating decimals are rational. What do we have here? The square root of 2. Well, first of all, we can put a square root. We can do it as a decimal. We can put it on a number line. We can approximate it. So it definitely is real. If you take the square root of 2, you're going to get a decimal. So it's not an integer. It's not a whole number. And it's not a natural number. Remember what I said about prime numbers. 2 is prime. The only thing that multiplies a 2 is 1 times 2, which means it's prime. If a number only multiplies by 1 to get that number, then it's prime. And if you take the square root of a prime number, it's always irrational. So P. If you do the square root of 2, it's going to go on and on forever, that decimal. It's not going to end. Are we okay? If you have questions, please feel free to put them in the comments or send me an email at betsysmathminute@gmail.com. All right. The next one, pi. Pi if you know what pi is, you know that pi is 3.14 and 15, and it keeps going on and on and on. So first of all, pi is a real number, that's for sure. So it's real, but it's a decimal. So that eliminates integers, whole numbers, and natural numbers. Because it goes on and never ends, it's irrational. Let's take a look at the next one, number 7. We have a real number, because it's a fraction, which we can put on a number line. If you divide that out, you're going to get a decimal. So it's not an integer, it's not a whole number, and it's not a natural number. But 1,111 is an integer, -8 is an integer. I have an integer divided by an integer, so that's rational. And we're done. Let's take a look at the next one, the square root of 36. Well, the square root of 36 can be put on a number line, so it's real. If you take the square root of 36, the square root of 36 says what times itself is 6. Well, 6 times 6 is 36. So the square root of 36 is 6. Is that an integer? Yes. Is that a whole number? Yes. Is that a natural number? Yes, we can count to 6. And if it's an integer, whole number, natural number, then it's rational. Oops, that's the wrong symbol. Sorry about that. We got to go back. So rational is Q. Make sure you simplify before you decide which sets your number falls in. How are we doing here? Let's take a look what Emoji Betsy has to say here. Let's just take a break for a second. Why did the real number need counseling? Because it couldn't handle its irrational behaviors. I thought that was appropriate for this playlist. All right, let's go on. The next one, 2,000. Yep, we can put that on a number line. 2,000 is an integer because it's a number without a decimal. It's a whole number because whole numbers are all the positive numbers and 0 that are not decimals. It's a natural number because we can count to 2,000, so it's a natural number. And because it's an integer, whole number, or natural number, it is rational. Oops, there I go, putting an R for rational again. See, I use RAT in my classroom, but rational numbers are Q. All right. One more, math mates. 3.57 negative. Well, I can put that on a number line, so it's real. It's not an integer because it has a decimal. It's not a whole number because it has a decimal. It's not a natural number because it has a decimal. And other things. Natural numbers and whole numbers can't be negative either. Now, does that decimal end? Yep, 0.57. It doesn't continue. So that means it's rational. Whew, that was a lot of work. I'm going to try to put some video or some extra problems together, and I'll put them in the math video playlist when I have some extra time. But this should be a good start for you. If you have any questions on those, please let me know. I will help you. All right, we still have a little bit more to go through on this section. I know it's long. Maybe you need to go get a latte, or go have your favorite lemonade or whatever it is that you like to sit down and chill and have to drink. Maybe grab a snack. I love chocolate, you guys. I can eat chocolate forever. So just go grab your snack or whatever it is that you want and pause the video, and I'll be here when you get back. Okay, math mates, I hope you were able to get your snack and you're back with me. This is just some additional information I'm going to give you. It might help you, it might not. I will add some examples to it, but it's just a little more clarification for you. So let's take a look at the first one. I'm going to change my pen color here. All right, it says, add or multiply two natural numbers and always get a natural number. So if you perform the operation and you get that set of numbers, then that says that it's closed under addition and subtraction or multiplication. So if I add, so let's go. Natural numbers are 1, 2, 3, 4, 5. So if I, for example, add 1 plus 5, I'm going to get a natural number, which is 6. Or if I multiply two natural numbers, 2 times 8, I get 16, which is a natural number, because your natural numbers are your counting numbers. We can count to 6, we can count to 16. So that means natural numbers are closed under addition and multiplication. If you add two natural numbers, you will get a natural number. If you multiply two natural numbers, you'll get a natural number. But why doesn't it work for subtraction? If I take the number 5 and I subtract the number 8, what is that going to give me? I've got 5 positives and 8 negatives. If I combine those, I get a negative answer. Are natural numbers negative? No. So it is not closed under subtraction. I do not always get a natural number. Could I get a natural number? Sure. 8 minus 5, that's 3. That's a natural number. But to be closed, it means it works every time. How about division? Well, if I take a natural number, 15, and I divide it by natural number 2, what does that give me? It gives me a decimal. So it doesn't always work for natural numbers. If you divide a natural number by a natural number, you're not always going to get a natural number. You could. 16 is a natural number. 2 is a natural number. 16 divided by 2 is 8. But to be closed, it has to work every time. Are we okay, mathmates? Just think about it for a minute. Now, I'm going to erase this because I want to make more room for the next one. So I'm just going to erase this out of here. So closed means it has to work no matter what. If you can make it not work, it's not closed under that operation. All right, here we go with the next one. The next one says, closed under multiplication, addition, and subtraction. And we're talking about integers. So if we multiply two integers, we're going to get an integer. If we add two integers, we're going to get an integer. If we subtract two integers, we're going to get an integer for an answer. That's what that means. So let's test it. Multiplication. -3 times 5. -3 is an integer. 5 is an integer. If we multiply them, we get -15, which is an integer. Remember, your integers are any number that's not a decimal. All right, adding 5 plus 3. They're both integers. I get an integer for an answer. Subtracting 7 minus 9. Well, if I got 7 positives and 9 negatives and I put them together, it leaves me with 2 negatives. We're going to be going over this in the next video. So if you're struggling with adding and subtracting integers, I'm going to help you with that. I've got different methods to show you. So in all these cases, we end up with an integer for an answer. And I just did one example, but there's no time when you take two integers and multiply them that you won't get an integer. And same with addition and subtraction. That's why they're closed. Now, if I take an integer divided by an integer, so -10 divided by 3, is that going to be an integer? Negative 10 divided by 3 is negative 3 1/3. Or negative 3.3 repeating. That's not an integer. That's why it's not closed under division. Could it be? Sure. Negative 20 divided by negative 2 is 10. Negative 20, negative 2, and 10 are all integers. But to be closed, it has to work every time. All right. Let's take a look at the next one. Add, multiply, or subtract two rational numbers and always get a rational number. It will work under anything except division. And only because division has 0, that won't make it work. Let me show you what I mean. I'm going to erase this one. Okay, we're erasing this. Remember, whole numbers, natural numbers, real numbers are all rational. So if I add two rational numbers, 3.8 plus 2. They're both real numbers. They're both rational. If I add those, I get a rational number. 5.8. It ends, the decimal ends, therefore it's rational. Now, if I take an integer divided by an integer, integers are rational numbers, I end up with a rational number. The only exception to this rule is if you're dividing by 0. Any number divided by 0 does not exist. That's why it's not closed under division, because of the 0. All right. So let's move on. If you need to take a break, stretch a little bit, use a bathroom, maybe even take a minute and meditate, whatever you need to do, relax a little bit. This is a long video, and I want to make sure you understand it. This is really important, especially when it comes to like standardized tests and that. You want to know these definitions. And the best way to do that is to keep going back over them. When you're watching your YouTube videos or watching a movie, take a break every so often. Maybe do a few push-ups or sit-ups and stretches, and just take this out and take a look at it. It'll help. All right. The more you look at it, the more you're going to remember. All right. All right. Oops, what happened to my whiteboard here? Kind of disappeared on me. Okay. So we've got one more page to look at, and then we'll be done here. Hold on, math mates. Let's not rush on this. It can get confusing. That is true. It can get very confusing. But we're going slow, and you're going to ask me questions if you're not understanding. Okay, let's take a look at the next one. It says whole numbers. Whole numbers are closed under addition and multiplication. Yes, that is very true, because your whole numbers are 0, 1, 2, 3, 4, and so on. So if I add two whole numbers, I'm going to get a whole number, no matter what. If I multiply two whole numbers, I'm going to get a whole number every time. Doesn't matter what it is, I get a whole number. Your whole numbers are 0, 1, 2, 3, and so on, no decimals. But if I divide two whole numbers, 4 divided by 3, that's going to give me a decimal, 1.33. So that's why it's not closed under division. If I subtract two whole numbers, 7 minus 9, that gives me -2. -2 is not a whole number. We're not saying that it can never happen, but to be closed, it has to happen every time. All right. Let's take a look at the next one. Addition, subtraction, multiplication non-zero rational numbers of an irrational number is always irrational. So if you add a rational number, if I add 5 plus 1/3, I'm going to get 5 1/3, which is irrational because 1/3 goes on and on. So if you take a rational number and you add an irrational number, you will get an irrational number. And it goes the same for subtraction and multiplication, as long as the multiplication number does not have a 0. So if I do 0 times any number, 0 times the square root of 2, because square root of 2 is irrational. Well, 0 times anything is 0, and 0 is a rational number. So the only exception to that rule is 0. All right. Addition, subtraction, multiplication, and division of irrational numbers may or may not result in an irrational number. So if you add 2 irrational numbers, you may get an irrational number or you may not. If you subtract 2 irrational numbers, so if I take 5 plus the square root of 2, let's say, and I subtract the square root of 2, I get 5, which is rational. Multiplication and division, the same thing. So if you take 2 irrational numbers and you add them, multiply them, divide them, or subtract them, you may get an irrational number or you may not. So it's not closed under any operation. So I'm hoping from all of this that you understand what it means to be closed. If whole numbers are closed under addition, that means every time you add 2 whole numbers, you will get a whole number. If whole numbers are not closed under subtraction, that means you could end up with a whole number, but you may not end up with a whole number. So closed means it happens every time. I hope this helped. Questions, put them in the comments, send me a Gmail. Whatever I can do to help, I'm here for you. Have an awesome day. And try to find some time to have some chocolate. All right. I appreciate it if you subscribe to, and please share. Thank you.